So I wanted to start section 5.3, and in 5.3 we are multiplying basically special case polynomials, and I'm going to start off with the generic principle, and that's the square of a binomial sum. And that's a complicated way of saying binomial is a two-term polynomial, and they're being added together, the two terms, and then squaring them, and that's what this a plus b squared is. And it winds up being a squared plus 2ab plus b squared. And this is a general rule type formula, and it works for everything that is put in this format. But let's see kind of how this formula is derived. So remember when we were doing the graphic organizers, right? And we put them in an array like so, and this represented multiplying. Well, you've got A and B here, and A and B there. And so this first one is basically A times A, right? And that's A squared. And this second one is A times B, and that's the term AB. This third one, again, is A times B, and that's the term AB. And then this last one is B times B, which is B squared. And so that means that essentially anything that's in this A plus B squared format winds up being equal to A squared plus 2AB plus B squared. And you're like, so what? That's interesting, but there's not even any numbers there. So how does that help me in any way? And I'm going to show you that basically if I know, say I have like x plus 3 squared, without foiling, without distributing, without multiplying this all out, this is going to be equal to essentially x squared plus 2 times 3 times x, which is 6x, and plus 3 squared. And, you know, if I can use this formula to quickly solve things like this without having to multiply it all out. And there's going to be a couple other special case things we're going to learn today as well. So here we go. We can apply this, right? Here's our A and here's our B. And remember our formula said this is going to be equal to basically A squared plus 2 times A times B plus B squared. Well, what's x squared? Right? X squared. And what's 4 squared? 16. And then all we have to do is, well, the second part, this is 4 times x times 2. So what's 4 times x times 2? 8x. Boom, done. So let's try another one. What is this squared? Right, that's basically 3 squared and x squared. So that's going to be 9x squared. How about this? What's that squared? That's going to be 4y squared. And then the center part, right, in the center basically goes 2 times 3x times 2y. So that's what goes in the center. So that's 2 times 3 times 2, 12xy. And I don't know about you, but that's like a lot faster than trying to do this mess. 3x plus 2y, 3x plus 2y, foiling it. First, outside, inside, last. Or, 3x times 3x plus 3x times 2y plus 2y times 3x plus 2y times 2y. and then like multiplying that all out, combining and gathering all your like terms, and then doing all that and still getting this. So this formula definitely saves us time. And if you're a mathematician, you're all about learning ways to do more in less time. Shortcuts, and this is a major shortcut. So here's another special case, right? If I have a and a minus b, and a and a minus b, and keep in mind, a and b could be anything, right? We're just saying basically you have something minus something else, and it's squared, right? This is equal to a minus b times a minus b. Remember, we're multiplying in this grid. Well, a times a is a squared. A times a negative b, negative ab. A times a negative b, negative ab. And then negative b times a negative b, positive b squared. So again, you get another basically general rule formula where a minus b squared is going to be equal to a squared, and instead of plus this time, it's minus 2ab plus b squared. So now let's see what that looks like with some actual numbers. So here we go with some actual numbers. And remember, the formula is a squared minus 2ab plus b squared, right? And here's our a, and there's our b. So what's x squared? And what's negative 5 squared? And then in the center, you basically have negative 5 times x times 2. And you get basically minus 10x. Right? 2 times 5 times x minus 10x. So let's try another one. Here's a and here's b. And to clarify, right, a is 6x, b is 1. So 6x squared, right, 36x squared. And 1 squared is 1. And now we have to do like a minus 2 times 6 times 1. Done. And I don't know about you, but that's a lot less work, at least for a problem like this, than 6x minus 1 times 6x minus 1, foiling it all out, or distributing it, whichever you prefer. So just again, the special case formula will help us out, and I have a feeling these are going to be future posters on the wall. So here's another special case. This one's called the difference of squares. Now, there's a particular student in my third period, and we were having a discussion about stuff like this, and they were showing me sample PSAT questions, and they were kind of thinking like that they had forgotten how to do stuff. And they were pleasantly surprised when I explained to that student that, oh no, you're about to learn this in about the next week or two. But the SATs presume you already have a knowledge of basically, I want to say 10th, 11th grade math. And so some of the stuff on the PSAT will be things that you haven't seen yet, because they assume by your junior year you would have seen him. But, and this is one of those things. So stuff like this is throughout the SAT and ACT and college math entrance exams. So here we go, another special case. Remember, we are multiplying in this grid, and we have an A and a plus B and an A and a minus B, and A times A is A squared. And A times B is AB. And then A times a minus B is minus AB. And then a minus B times a positive B is a minus B squared. And the reason this is called the difference of two squares is because the actual answer, right, this and this wind up canceling each other. So the actual answer winds up being A squared, which is something squared, minus B squared, which is also something squared. Hence, the difference of squares. Now let's see how that applies with actual stuff. And this might be one of the biggest shortcuts that we're going to learn of all today. Oh, look, I have stuff with numbers. And hopefully I can recognize that this is an A plus B and an A minus B situation. And hey, instead of multiplying all this out and possibly making a bunch of errors, if I just simply remember my special case formulas, such as the difference of squares. I mean, this is basically, it's just this squared and minus that squared. Done. All right, I applied the formula. The formula is A squared minus B squared. Look, another difference of squares. Right, A plus B times A minus B. And it's this squared, which is x to the fourth, minus 2y squared. Well, 2y squared is 4y squared. A lot less work. I hope you like these shortcuts. It does make your life easier when multiplying certain cases of polynomials. And now that I took you through the basically the formula parts, along with some examples, let's take it back to algebra tiles, right? If we were multiplying these things with algebra tiles. And, right, maybe now you'll see, wow, algebra tiles could take a lot longer. Yeah, but there's definitely value in doing it with the algebra tiles as well. Right, and then it's less abstract, I find, because you can actually see what's happening. And so all of these are going to be x squareds. These are going to be some more x's. And these are going to be some more x's. And I'm just drawing all these little tiles the fast way. So what do you wind up having? Right, there's 4 x squareds. There looks like 12 x's and 9 of those things. 4x squared, 12 x's, and 9 of those things. And right, wasn't the formula for this one a squared plus 2ab plus b squared? Well, what's a? A was 2x. And what's b? B was 3. Well, what's 2x squared? And what's 3 squared? And then what's 2 times a times b? 4x squared, 9 And this is 2 times 2x times 3, 12x. So here you can see how the formula and the algebra tiles, it all gets us to the same place. So let's try another one with the algebra tiles. Right, this is going to be 4 of these things. And then we're going to have some negative x's. And I'm going to show that with all my little lines. And let's see, these are going to be also negative. And again, you're going to get, I'm going to do this a quick way, 9 of those things. And they're all negative. Oh no, they're not negative, right? Negative and negative make positive. So those are all positive. So what do you wind up having? That's 4x squared. You got minus 12x plus 9. And you'll recall, right, the formula for this thing, if I had a minus b squared, it was a squared minus 2ab plus b squared. Well, right, our a is the same. Our a is 2x. Our b is 3. And then 2ab minus 2ab. Right, what's a squared? 4x squared. What's b squared? Plus 9. And then what is minus 2 times 2x times 3 minus 12x. See the formula and the algebra tiles, they get us to the exact same place. And now let's do this last example, right? This is clearly the difference of squares. This is a minus b, or I should say a plus b times a minus b, and you recall that was just a squared minus b squared. And I'm going to do it with algebra tiles, but right, if I can identify that a is 2x and b is 3, well, what's a squared? Right, 4x squared. And what's b squared? 9. So the answer I'm going to get with the algebra tiles should be 4x squared minus 9. So let's see if that's what we get. 4x squared. Certainly looks like it. You're going to get some positives. And then you're going to get some negatives. And then I'm going to draw the grid in the sake of time. And then these are all basically negative. Right, and these positive will cancel with these negative, and you do in fact get basically 4x squared, 0x, and minus 9. So there you go. That's this section. We'll do some practice on the textbook examples, and then we'll have a test after some test review. But hopefully this section also is not very difficult compared to some of the stuff we started off in the beginning of the year. So another chance, I hope, to get a good grade.